In this video, we're going to look at the common calculations used in Year 11 and Year 12 chemistry. Concentration can be looked at both qualitatively and quantitatively. When we're looking at it qualitatively, we use the terms dilute and concentrated. Now, what do they mean? We know a solution equals both a solute plus a solvent. So when we're talking about dilute, that means there's a large amount of solvent and hardly any solute. Now, when we're talking about concentrated, then it's the opposite. There's a large amount of solute and hardly any solvent. When we're looking at concentrations quantitatively, then we need to actually know the actual amount of solute particles per volume of solvent or solution. Now, the four ones that we're going to be looking at are grams per litre, percentage composition by mass, parts per million, and moles per litre. Now let's look at the first example. The first type we're going to look at is grams per litre. As the name suggests, this is the number of grams or the mass of the solute per volume of solution. So the concentration here, the mass is in grams, the volume is in litres, and this will give us a quantity of grams per litre, which is the unit for concentration. Now let's look at an example. It says calculate the concentration of copper 2 sulfate if Emily dissolved 15 grams in 100 ml of water. So the concentration is equal to mass over volume. Now I'm telling my marker what I am doing because my marker needs to be my friend. So the mass in this case is 15 and the volume is 0.1 of a litre. So 15 divided by 0.1 is 150 grams per litre. Now don't forget significant figures. Now this is a bit ambiguous. We're going to say 3 significant figures here. Now it is time to stop this video and go to the OneNote to try an example. I'll put the work solutions on space for you to check. Our second type of calculation is a percentage composition by mass. This represents the mass of the solute in grams divided by the mass of 100 grams of solution and can be calculated by using mass of solute divided by mass of solution times 100. It's like any other percentage, the bit over the whole times 100. Now let's look at an example. So we've been asked to find the percentage composition by mass of sugar in a solution. So we're going to do percentage equals the mass of the solute over the mass of the solution times 100. So the mass of the solute is 22 grams over the mass of the solution. Now remember, a solution consists of both a solute and a solvent. So the solute is sugar and the solvent is water. So the mass of the solution is solute plus solvent times 100. So this comes out to 22 over 122 times 100, which comes out to 18.0%. And I'm going to do my answer to 1, 2, 3 significant figures. Now it is important that you try one yourself, so stop this video, go to the OneNote and do the example. The worked examples can be found on Space. Our third example is parts per million. This is used when we have very, very dilute solutions. It is representative of a mass of a solute in milligrams dissolved by the mass of the solution in kilograms. The formula here can be found on the data sheet. Now my experience is, for some unknown reason, Year 11 and 12 students have difficulty converting to milligrams. So there is an alternative way to do this. You can just do parts per million by mass of the solute in grams divided by the mass of the solution in grams and times it by a million. The million is in the name. So this is my preferred method of teaching it, but I will show you both. So let's watch this example. I'm going to do it both ways just so that you're familiar with both. So it says here that we have 0.0034 grams of chlorine in 250 grams of solution. So parts per million is equal to milligrams of solute over kilograms of solution. So we're going to have to find the solute in milligrams. So if the mass of the chlorine is 0.0034 grams, then to convert it into milligrams, we have to times it by 1,000. So this timesing it by 1,000, 1, 2, 3, is 3.4 milligrams. Now the mass of the solution is 250 grams. So to convert it into kilograms, you need to divide by 1,000, which is 0.25 kilograms. So now that we've got the mass of the solute and the mass of solution, we can substitute it in. 3.4 divided by 0.25 comes out to 13.6 parts per million to 3 significant figures. Okay, now let's do it the alternative method, which I think is much easier for Year 11s and 12s. Parts per million is equal to grams of solute over grams of solution times by million, and a million is 1 by 10 to the 6. So it is 0.0034 divided by 250 times 1 by 10 to the 6, and as you can see, it comes out to exactly the same number. And I think this is a better method for you to use. Now it is important for you to try one yourself. I'd like you to stop this video, go to the OneNote, Solutions, Concentrations of Solutions, and try the parts per million question. You will find worked answers on Space. The most useful way for chemists to find a concentration is to use moles per litre. Remember, moles are the fundamental unit in chemistry. Now in this formula, the concentration is equal to the number of moles of solute and divided by a volume in litres, and this will give you an answer of a concentration in moles per litre, or quite commonly known as the big M, which is for molar solutions. Now this formula is found on the data sheet, but it's not written in this format. It's actually written as the rearranged version of number of moles is equal to a concentration times a volume, and you'll find this in the formulas on your data sheet. Now let's do a few examples ourselves. It says calculate the concentration of 12.5 grams of copper 2 sulfate in 250 ml of solution. Now as I said, our preferred concentration is moles per litre. So the first thing we're going to have to do is convert this to moles. So number of moles of copper sulfate is equal to a mass over a formula mass. The mass in this case is 12.5 grams. I go to my periodic table to find the formula mass of copper sulfate, which is 159.62, and I calculate the number of moles, and the number of moles is 0.0783 moles. Now, it's best not to round until the bitter end, so store this information as you require it. Now, to calculate the concentration of copper sulfate in solution is equal to number of moles over a volume. The number of moles is 0.0783 divided by a volume. Now, this must be converted to litres, 0.25, and it comes out to a concentration of 123 significant figures, so 0.313 moles per litre, or as I used before, the big M, molar solution. Now let's try a third example. With this third example, we are now going to find the moles of calcium chloride in 50 ml of 2 molar solution. So I'd go to my data sheet and pull the formula. Number of moles of calcium chloride is equal to CV, which is equal to 2 times 0.05, converting this to litres, which is 0.100 moles. In our third example, we're going to look at how to calculate the number of moles of ions within a solution. So in this example, you've been asked to find the magnesium ions and the nitrate ions in 150 ml of 2.15 molar magnesium nitrate solution. So step number 1, find the moles of magnesium nitrate. And we're going to go to our data sheet and find that the number of moles is equal to concentration times volume. So the concentration is 2.15. The volume is 0.15, because remember we have to convert it to litres, and this comes out to 0.3225 moles. Now in our second step, we're going to use interpretation of formula to find the number of moles of magnesium ions and the number of moles of nitrate ions. So looking at the formula, the number of moles of magnesium ions is going to be the same as the number of moles of magnesium nitrate. Now we can tell that because there is 1 mole of magnesium within a magnesium nitrate. So this means it's going to be equal to 0.323 moles. Now let's find the number of moles of nitrate ions. Now the number of moles of nitrate ions will be equal to 2 times the number of moles of magnesium nitrate. Now we know this because we can interpret our formula and see there is a 2 there. So 2 times 0.3225, and this will come out to 0.645 moles to 3 significant figures. It is now important that you try one yourself. I'd like you to go to the OneNote, go to concentrations of solutions and do the examples on moles per litre, and you'll find the worked answers on space.